to talk about how to use the properties of exponents with scientific notation. Now, a quick reminder of scientific notation. If we have a really big number, 12,570,000, and I want to write this using scientific notation, I'm going to want one number in front of the decimal point, and then all the other digits are going to follow. Then you need to tell everybody how many zeros you didn't write by multiplying it times 10 to some power. Now, if I currently have my decimal place here and I need to move it to here, I'm going to have to go 7 places. So you're going to have 10 to the 7th power. Now, the same thing's going to work if you have a smaller decimal. Right now I have a decimal in the front of all these zeros, and I need to move it to just behind the 3 so that I still have one digit in front of my decimal place. Oh, let me find you a color. Well, that works. And decimal place, and then the 5 and 6 are going to follow. And this one's times 10 to 6. So we're going to have 10 to the negative 6 power. Now, I find my students have a hard time remembering whether you're going to have a positive number or a negative number. And here's how I always remember, is if your standard number, and we have scientific notation, if your standard number is bigger than the scientific notation number, then you're going to have a positive exponent. So you'll notice I had 12 million and I changed it to a 1. So obviously that's going to be bigger. Now, if your standard notation is less than your scientific notation, you're going to have a negative exponent. Probably not scientifically correct, but that's how I remember. Now, in my Algebra 2 class, we frequently end up with expressions where we have scientific notation and we have bases of 10 that we can put together. Now, the shortcut for this, instead of having to use all of our decimals and move everything around, is if you have a 9.3 times 10 to the negative 3 power, that's the same thing as saying I have one base, A, times the second base, B. And if you recall from our properties, I'm allowed to split them up. Okay? So, if I'm looking at this particular property, I can just deal with the 9.3 and the 1.3 all by itself. So I can take 9.3 and just divide it by the 1.3. And what you get is 7.0. So all I did was divide. And I divided just the regular numbers. Now these tens, they have the same base. And if you recall, when you're dividing the same base with different exponents, all you have to do is subtract the exponents. So we're going to have times 10 to the negative third over 10 to the 8th. And if you take a negative 3 minus an 8, you're going to end up with a negative 11. So this becomes times 10 to the negative 11th. Alright, let's look at another example. This one has to do with multiplying. Same properties apply. If I take the regular numbers, 3.5, and I multiply it times a 5.2, I end up with an 18.2. Then if I take my tens, you'll notice that this time I'm multiplying them together, so I need to add the exponents. So I end up with a 13. So I have 8.2 times 10 to the 13th. Now, normally my students are going to want to stop, but this is not scientific notation. Because I need to have one digit in front of my decimal. So I know I'm going to have a 1.82. And I know that I needed to move it one spot. Now, in order to decide whether I'm going to add 1 or subtract 1, my 18 is actually bigger than my 1. The 18 from here and the 1.8 from here. So this means I need to add an exponent. So to that 13, I'm going to add one more place. So we're going to have times 10 to the 14. Hopefully this helped a little. If you need some more information, please ask your teacher.